Alright, so, we're going to be talking about the median of data, that's lesson 13, and then we're gonna be talking about comparing mean and median, that's lesson 14. So we're doing two lessons together today. We are gonna have to do the dot plot. I know that we haven't technically talked about graphs yet, but I'm not gonna expect you to just do this all on your own. So we're gonna do a lot of work together today. And then you will have your cool down at the end of class. Okay, questions? Got it? Thursday, 6 days till spring break. Thank you for being here excited. I don't know how excited. Alright, so let's jump right in and look at 13.2, so siblings in a house. It says, here's a table that shows the number of siblings of 10 students in Tyler's class. Represent the data shown in a table with a dot plot. So, the way that you can do a dot plot, is essentially it's kind of like a number line. So looking at our data, the very first thing we want to do is what? What do you think we want to do with our data so it makes it a little bit easier when we figure out how to do our number line?
Put them in order,
From,
least to greatest.
yes, so looking at our numbers, we have 0, 0, 0, right, 3 zeros. All right, then what number comes next? Joe?
1 and 1 and 1.
So we have 3 ones as well. And then what number comes next?
2.
Do we have 1, 2, or 2 twos?
Just one.
Are you sure?
2.
Okay. And then what comes next? Isabella? And then 10. All right, so essentially looking at our data set, what do we know about our number line? Like, what does it have to have on it? Addie, what do you think? Like what, let me rephrase that question so that I don't make it confusing. What numbers does it have to have on it? Okay, so can we make a number line that has 0, 1, 2, 7, 10? Or do we need to make a number line that has 0 through 10? Okay, and this is the difference between like a dot plot and other graphs. Like if our range is 0 to 10, even though we don't have 3, 4, 5, 6, 8, 9, we still have to have those numbers on our number line. So over here we're gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8. My number line is a little too small. 9, 10. Okay, give me a thumbs up when you have that done. Okay, so now we have our numbers in order from least to greatest. So if we have 3 zeros, how many dots do you think we're putting above 0? Indira? Yeah. So you're just gonna go 1, 2, 3. Hence the name dot plot. Okay? So we've used those, so I'm gonna just cross these off so I don't get confused. Alright, then we have 3 ones. So how many dots am I putting above the 1? Abby?
3 ones.
Alright, so 1, 2, 3. And then I have 2 twos. Lily? I have 1 7. And I have 1 10. Okay? So this is how you construct a dot plot. Questions? No? Yeah?
I remember this.
You do remember it?
Yes.
Okay.
I don't remember the first part that we've done this, but I remember doing the dot plots.
Okay. And you guys should have learned dot plots in 4th grade. So, and again, that was, if you think about it, that was the beginning of what?
The
COVID, pandemic, remote learning, so, we're gonna take statistics a little bit slower than we originally were planning, just because it's not a huge part of the EOG, but it is important. It's actually a very good skill to have for life. So, if you don't understand some of the stuff we're doing, please ask, please be like, Miss Kenny, I'm confused, I'm not sure how you did that, and I'll do my very best to make it as easy as possible. Yes, sir.
What are the most questions about EOG?
The most questions are expressions, equations, and ratios, proportions, percents. Yeah.
It's like half of
Alright, let's get through this lesson now. Alright, so based on your dot plot, estimate the center of the data without making any calculations. What is your estimate of a typical number of siblings of these 6th grade students? Mark the location of the number on your dot plot. So where do we think our median is? Like the middle. Remember, the median is the middle. So where do you think the middle of our data is based off of where our dots are located? You think 1? Okay. Does anybody else think something different? What do you think?
I think 2.
2? Okay, so I want you to take just a different color or like an open circle if you don't want to use a different color. And I want you to put your dots where you think the middle is. So if it's 0, 1, 2, 4, 5, it might fall on one of these numbers that we have not put any dots on as well. So if you think it's going to be one of those, do that.
Are we standing up
That'd be great. Thanks. I'm gonna say some of them. I don't know if that's right. That's just what I think. All right. Levy, what number did you pick?
I put 5, but I think it's like between 5 and 6.
Okay, so like 5 and a half. Okay, why did you pick 5 and a half? Sorry.
Because, I don't know. Well, if it would be between 1 and 10, it would obviously be 5. But since we have an extra number, I just put it between 5 and 6.
Okay, I like his reasoning. He said because if you're looking at the numbers 1 and 10, half of that is 5, but we have an extra number, so he made it 5 and a half. Perfect reasoning. All right, does anybody have something different? Anybody else? All right, Lily?
I chose 1.
1?
Yes.
Okay, why?
Because, from what we had tried timing, I kind of like did it in my head about the numbers and like kind of the crossing thing off in my head and stuff, so instead of actually doing it on a paper. And I got to the middle.
Okay. All right, so you did a little bit of math.
Yes.
A little bit of math. Okay, and that's fine. I mean, it's kind of hard not to do some math. I mean, even Levy's reasoning was a little bit of math, right? All right, Gabby, what'd you come up with?
I did 2,
Okay.
because there's 6 dots on one side, and then if you put it on 2, there's 4 dots, only technically on the same and other side, so between the 2 of them is like 2 to me, because I didn't want to do like 1 and a half, because you can't have 1 and a half siblings.
Okay.
It's true.
Alex, I'm speaking on your iPad. Okay, so you cut your dots in half, not the numbers. Okay, so you didn't necessarily look at the bottom row, you looked at how many dots you had, and that's fine too. All right, so technically, if you're between like 1 and 2, that's fine. That's essentially where we want to be. But now we're going to actually find the mean. So how do we find the mean? What do we got to do? What do we have to do to find the mean? Elizabeth.
Line our numbers up, is greatest.
And then what?
Actually,
It's okay. It's okay if you forgot. You're right. So we start with lining our numbers up, right? Okay. Brielle, give me the next step.
You add all the numbers together.
So I'm going to add 3 zeros plus 3 1s plus 2 2s plus 7 plus 10. All right, go ahead, add those numbers, stand up when you have your answer, please. We're not doing anything but adding right now, okay? This is just step 1. All right, Benjamin, what you come up with? All right, so we have 24. Now, so Elizabeth told us numbers orderly to greatness. Brielle told us add. What's the next step that we have to do?
You have to divide all of the numbers
By.
by how many numbers you added to it.
Okay, and how many numbers did it tell us that we were gonna have? Where's it at? Up here. So 10 students, so what are we gonna divide this by? 10. All right, so when you divide 24 divided by 10, you get 2 and 4 tenths. That is technically your mean. That is your average. Okay? All right, slide up to number 4. We're still using that same data. So it says, how does the mean compare to the value that you marked on the dot plot as a typical number of siblings? Is the mean that you calculated a little larger, a lot larger, exactly the same, a little smaller, or a lot smaller than you estimated? So now, our mean we know is 2 and 4 tenths. Look at where you put your dot or your open circle and just write an explanation. Was it a lot larger? Was it very close? Was it a lot smaller? Just write an explanation for where your dot is to the actual mean of our data.
May I have your attention, please? I need the following students to report to room 502 with your iPad. Jules Branton, Tyler Braswell, Aiden Burton, Lane Cox, Crosby Darnell, Tyler Gross, Sarah Nanny, Ben Rowe, Davinia Steinmetz, Anna Stewart, Colleen Taylor, John Turberville, Juliana Vasquez, and River Volpe.
All right, so looking at where I put my dot, I said my dot is a little larger than the actual mean because I put my dot on 3. Okay, who would like to share kind of where their dot was and their explanation? Joe?
I said my dot was a little less than what the answer was because I did 2. Because I had counted and there'd be 2 on the side like Daddy's, but 2 on this side and then 2 on this side and then 2 would be in between. And then I thought the answer would be 2 or somewhere around 2, so that's my answer.
Okay, cool. So you were very close actually. If your dot was 2 and our mean was 2.5, so perfect. Anybody else want to share what they wrote? Juan, do you want to share? Well, let's start. Where did you put your dot?
At 2.
At 2? Okay, so then what would your explanation be?
I was very close.
Right, he was very close, very similar to Joe. I mean, if you're putting your dot at 2 or around 2, and our mean was 2 and 4 tenths, you're pretty close. All right, and then 4B, it says, do you think the mean summarizes the data set well? Explain your reasoning. So this is where we have to kind of learn a little bit about like the type of distribution within our data. So the mean, again, is 2 and 4 tenths. This is what our data looks like minus our point or our dot that we added. So 2 and 4 tenths, do you feel like it summarizes the data well, knowing what numbers we have? So look at, so this is technically, let me do that. So that is technically the mean right there. So look at our data. How many numbers are below the actual mean and how many numbers are above. So how many numbers are below our mean? Just count the dots, not the ones that we added, but just count the dots that we started with. Maria?
There are 8 below the mean and 2 above.
Right, so does the mean describe our data very well? Because isn't the mean supposed to be in the middle? I mean, technically, it's supposed to be about the middle of our numbers. So this would be a no, because of there being so much more data below the mean than there is above the mean. Alright, so please add no because we have 8 dots below our mean and only 2 above it. It should be more in the middle. You can even add in our data or just more in the middle. Andrew, Chris is outside. Do I need to send you to him? All right, let's go ahead and slide down to the next one. What are you doing, child? A what?
I'm trying to find a glue stick so I can glue up this whole mess over here. And then there's a hole in our thingies, whatever these are.
There's about 40 holes in the bins.
Yeah, but there's a hole in our.
In the bag that the
So why don't we take this bag of wonderful chips out of it and say, hey, Miss Kenny, you want this back so we stop making so much noise?
What this?
Oh. What are you
Oh, I thought I dropped it.
Where's the hole? Oh, right there. Oh, that's an easy fix. You said, hey, can I borrow some tape? Tape the bottom of it. Maybe if y'all would play with the scissors and cut holes
I
in
didn't
that.
play with the scissors.
Y'all don't have no scissors? Well, Abby has scissors because she's always cutting on my center's directions. Who?
Well, I literally touched it.
These guys. Group 8 is a hot mess, y'all.
I know.
Okay, are we ready to focus on the next part of our lesson? You sure?
Yeah.
God bless us. All right. I'm not going to give you an index card. We're just going to do this together. So it says, write your first and last name, just right underneath here. And then we're going to record the total number of letters in your name. All right? So, like, you're going to write first and last. So I would write my first name, and then I would write my last name. And then I would count how many letters are in my first and last name and write that number.
Can you put both?
Whatever you want. Whatever you want. All right, once you have that done, we're gonna move on. So this is the data set that we just dealt with, right? And it says sort the data from least to greatest, then find the median. All right, least to greatest, find the median, stand up when you have your median. If you're not sure how to find the median, make sure you have your foldable out from yesterday. Alright, so what is our median? Or first, I guess, tell me how to find the median with this data set. Bryson, how do I find the median? What do I need to do? Did you get out your graphic organizer and look at it? Because if you didn't do that, I'm really confused as to why. Alright, so I'm gonna cross off until I get to the middle. And I'm left with 2 ones. So if I add 1 plus 1, because that's what it tells me to do, so 1 plus 1, I get 2. 2 divided by 2 equals 1. So my median is what? 1. Is that what we got?
Yep.
Okay, did anybody get something different? Alright, go ahead and open your page. In this situation, do you think the median is a good measure of a typical number of siblings for this group? So do you think 1 is a better measure of the middle than the 2 and 4 tenths that we just had? So I'm gonna go back to here, and essentially, the median is 1. So 1 being here, do you think that is a better measure of our data now? So you're saying yes? Why?
Because now at least it's more data that's on the side that. Do you know what I'm trying to say?
I do know exactly what you're trying to say, and I'm trying to find a color. So essentially, if I used my dot plot to find the median, I cross off, don't do this, just watch. So I mean, essentially, this is technically our new median. So now I have 1, 2, 3, 4, and then I have 1, 2, 3, 4, 5. So is that a better location of the middle of our data? I mean, technically, that's not the exact median, but do you get my point? So is it more in the middle rather than 2 and 4 tenths? All right, and that's exactly what we're gonna say right there, is that it's a better measure of the middle. So yes, it is a better measure of the middle of our data. Here, will you go ahead and turn that light on for me? Wash your eyes, y'all. Alright, number 3, it says here's the dot plot showing the travel time in minutes of Elena's bus ride to school. Find the median travel time. Be prepared to explain your reasoning. Alright, can you use the dot plot to find the median without putting your numbers in order? Without using any numbers, can you use the dot plot? Did you see what I just did last time? So let's go ahead and do that. So we're gonna start at the beginning. I'm gonna cross off a 6, then 12. 6, 10, 7, 10, 8, 9, 8, 9, and I'm left with 8 and 9. So what do I have to do with these 2 numbers? I'm gonna have to do with these 2 numbers, okay? So I'm gonna do 8 plus 9 equals, and then what do I do with 17? How many numbers do we have? No. How many numbers did we just add? 2. And then when you do that, you get what? 8 and a half?
Yeah.
8 and a half. So technically, our median is right there. Now, when you have 2 numbers in the middle like this, and you add them together and you divide, you're finding the average. You're finding the mean of those two numbers. So it's just like finding the mean of a big data set. You divide by however many numbers you just added, you're always going to divide by that too. Okay? All right, and then 3B, what does the median tell us in this context? So what does the median tell us? We got 8.5. What does that tell us? Addie, what do you think it tells us?
It's around more in the middle of benefits.
Don't be so contextual. Be a little less contextual. Like, what is that dot plot? Like, what do the numbers on that dot plot represent? Okay, so then if our median is 8.5, what does it tell us? For her to get to school, right? Okay, and it's that simple. So it takes her round, like, average 8.5 minutes to get her travel time to school, however you want to put that. Yes.
Also, what I noticed was on each side of the on each side of the 8.5s, they both have 6 on each side. Also, it's the exact same numbers, so it's showing right in the middle. On each side.
Yep, so they both have 6 numbers on each side as well, okay? So, I mean, it's definitely a good measure of the average time. All right, how do I want to say this to make it as easy as non-confusing? So the majority of her trips take about 8.5 minutes. Does that make sense to you guys? All right, when you're done, go ahead and slide over to lesson 14. Give me a thumbs. Actually, go ahead and stand up so I know that you guys are ready to go. Okay, so I know that this talks about the tallest and the smallest in the world, but we're actually, the reason I had you take your data is I was not gonna go around and measure and ask each one of you like how tall you were, because it would take us 45 minutes. But, well, I think are we doing centimeters? Are we doing feet? Like, no, I'm not. Whoo, no. So, that's why I had you write your name down and take that data. So what we're gonna do is I'm simply going to go around and you guys are gonna tell me how many numbers were in your whole name. So Ryan.
10,
Bryson.
10,
Addie.
8,
Kira.
9.
Ariana.
11,
Joe.
12.
We're 10.
Baby, what did you write on the paper?
10.
Savannah. Gabby.
15.
Callie.
11.
Cam.
14,
And Adira. 13. Faith.
12.
Andrew.
14,
Salmani.
14,
Abby.
10,
Brielle.
11.
Marion.
11,
Gracie.
13.
Lily.
12.
Levy.
12.
Elizabeth.
15,
Alex.
17,
Beth.
16,
16.
Yep.
Isabella.
20,
And Juan.
13.
13. Alright, so that is our data. This is the data that we are going to be using to answer the lesson 14 questions. So when it says like height, don't be like, Miss Katie, check them out. Talking about the number of letters in our names. Okay, can we follow along with that? No. Alright, so the very first thing we're gonna do is we're gonna find the mean height of your class letters. Okay, so we're gonna find the mean number of letters in your name for the class. Alright, how do we do that? What's the mean? What do we gotta do to find the mean? What do we gotta do to find the mean? Kira.
Put your numbers in order first.
Alright, so what is the lowest number we have? Lowest number. Alright, Amara.
8.
So 8. Cross it off. Then we have 9. Cross it off. Do you have any more 9s?
No.
Alright, how many 10s do we have?
5.
So 1, 2, 3, 4. 1, 2, 3, 4, 5. That's really hard to write a number and count. If you've never tried it, don't. Alright, how many 11s do we have?
4.
1, 2, 3, 4. Alright, do we have 12s?
Yes, we have 2 of them.
3? 3? Alright, do we have 13? So 1, 2, 3?
4.
4? So I can keep you guys around. 14s?
1, 2, 3.
15? 2?
We're gonna color markers.
16? 17, 20. Alright. If you were not copying this down while we were doing it, go ahead and copy this down. What are you laughing at? Copy it down. Don't be lazy. Alright, I think if I added this correctly, you should get 324. Alright, how many numbers are in our data set? So count the numbers that are in our data set.
I didn't count them.
Okay, count the numbers in our data set and raise your hand. Real?
6.
Well, how many do we have in class? So it should be 26. So we're gonna divide this by 26, and our average number of letters in our name is 12 and a half. Okay, so that is the average number of letters in the names of our classmates. All right, now it says find the median number of letters, and then, write that down. So, you can use the data set that you just wrote down, even though you didn't want to, you're welcome. I'll wait. And then stand up when you have your median. How many of you guys got 12 as your median? Okay, all right. So now let's slide down. And we're just going to adjust, again, we're taking context of one thing and changing it to another. So suppose that someone joined our class and had a name that was, give me a number greater than 20. Not like crazy, but, Isabel? 26. Okay? So we're gonna talk about how these next two questions. So how would the mean change with this number being added? Would it go up or would it go down? Or would it stay the same? So if we added 26 to our data, stand up if you think your mean would increase. So it would no longer be 12 and a half, it would be a greater number than 12 and a half. So stand up if you think that. Okay? Have a seat. Stand up if you think it's essentially going to be the same. It's going to be 12 and a half. Okay? And then stand up if you think it's going to be less than 12 and a half. Sorry, why? Why do you think it's going to be less?
For a reason, because if you add 26, 350 divided by 27, most likely it's going to be a smaller number because that's the bigger. I don't know what I'm trying to say.
Okay, so Addie's thought process is right in the fact that we're adding that 26. We do get 350. When we divide it by 27, our mean becomes 12 and 96 So her logic was right. Like when you're adding the number larger, it's going to increase your mean. What happens if we added a number that was smaller than 8? What would happen to our mean then? Instead of adding 26, what happened to our mean if I added, say, 5? What do you think?
It would decrease.
Good what? So if we added a bigger number and
It'd get bigger.
Listen, y'all. Listen. This is common sense kind of thing. So if you're adding a larger number, your median or your mean is going to get larger. If you're adding a smaller number, your mean is going to get smaller. Does that make sense? Okay. All right. Would our median change? So crossing over numbers, front back. Would our median change? So if I added one more number here, that'd give me 27. So instead of it being in the middle of these two 12s, it would be just this one 12. Would our median change? No, it would not. Okay? So we just found our new mean. So we did 350 divided by 27 gave us 12.96. But if you really wanted to play with nice numbers, you just round up to 13, but we're not going to. We're going to keep it very specific. And then our new median is just 12. For the purpose of what I just showed you. So it becomes an odd number, and it's just simply 12. Okay? Questions? Don't overthink statistics. That's what I need you not to do. Like, statistics is very common sense kind of thing. All right, D says, which measure of center, the mean or the median, changed more when this new person joined the class? So did our mean change or our median change? Which changed more? Or which changed at all? Elizabeth? The mean changed. And why did our mean change? Joe?
Because we added a number bigger than our original biggest number.
We added a number bigger than what?
Bigger than our original biggest number.
That's supposed to be that. All right, flip the paper over. Number 4, the world's smallest adult is 63 centimeters tall. Suppose the world's tallest and smallest adults join your class. So we already added our 26 here, right? So what is the person who joined our class with the smallest name? What number do we want to use? What number? Alex, what number? Doesn't matter, just pick a number lower than 8. 2? Okay. All right, you are essentially answering, you're gonna talk with your group about 2A, the questions we just talked about, and then you're gonna find the new mean, the new median, and then answer D. Okay? Go ahead.
A really small goal.
We have too many.
P-O. O. That's his name.
They have
P-O.
Why not lose?
Slash. How did you? You. You by itself, just you.
Oh, by itself. Oh.
You have the one who shall not be named.
You don't know. You're so lucky. So now we have to find a median. No, it's my favorite fan. It's the only fan I'll ever get.
It will probably get smaller.
Why?
It's the most ugliest fan I've ever seen.
I'm like, actually. Oh, you are taller. too. Like, no, we did it right. Okay, so. Be sure to do this. Okay, so we gotta find B's and B's. So I know the value, so I had 26 to what was the most uh-oh. Oh, we're gonna be now.
Wouldn't it go back to characters? Wait, no. It would. Oh.
So what is no. So we didn't have
So yeah, essentially you have like last week found, was it 26, and out of 26 was added, but 2 is also added. No, because remember, like, that's just our guideline, not like, that's why I had Alice just pick a random number.
divide that by all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Divide that.
Taking 126, we can put 35 once, and then so
'Neighbor, you know.
the best ingredient ever. Paper.
Yeah, but add, like, one of the ones, yeah, just add it.
So what was your meaning?
Let me do this one.
It just changed my life.
Pick one calculator.
So you got that. So what was our original one?
If you know the thing.
Right. So I mean, it's essentially 6 across both sides. But, I mean, like, this is where this is a little crazy. When you know what the min measure set, that's what we're looking at, right? It's true. Is understanding if you add just a small number, it's not going to change a lot. If we added, let's say, somebody came in here with 50, that is drastically improved our community. Okay? So, but no, it's all, okay. All right, let's go ahead and go over this because we do have one more activity that we're gonna do today with this lesson.
Yes, ma'am.
Okay, so what was our verdict? So the new mean, make sure that you guys included the 26, because our new mean is gonna also include this too. So we're gonna have the 26 and the 2. So you should have ended up with 352 divided by 28. Is that what you guys did?
Yes.
And then you ended up with 12 and 57 hundredths and some change. Well, a couple more decimals, but that's what you should have ended up with. So Addie said, okay, Miss Lynn, I'm confused because we added a smaller number. So shouldn't our average have decreased? Well, think about your average here. Did it decrease? It decreased, so y'all are telling me, God bless us all, this is not bigger than that?
It is. You're confusing me.
Y'all,
It's bigger.
is 5 less than 9?
Yes.
So then therefore, the average before adding the 2 was 12 and 96 hundredths. Once we added our 2 and found our new mean or our new average, it became 12 and 57 hundredths. This number is smaller than this mean. Does that make sense? But you're gonna be like, Miss Kenny, it's not smaller than the original. No, it's not, because we've added 26 and 2 to our total. So that's why it's not smaller. And this is where I was telling Addie, like, we're essentially talking about the center, or the measure of center. So we're adjusting our center by a couple of numbers each way, right? We added 26, it increased. We added 2, it decreased. What I need you to understand from this lesson today is essentially, if you add a bigger number, your mean is going to change to a higher number. If you add a lower number, it is going to change to a lower average. Does that make sense? That's what I need you to understand. So yes, technically from this mean, it did change. It decreased. All right, did your median change? Your median should still be what? Should still be 12, because if you slide over, I mean, technically it'd be what? What's 12 plus 13? You're saying no? Why?
Because if you add 26 here and 2 here, that's still basically just 2 more added numbers. That it wouldn't be 12 or 13, it'd still be 12 and 12.
And this is a great thing to do, because based off of what Addie said, we should be right, correct? We should still have 12. And if I miss a number, please let me know. So these two are our median. So is what Addie is saying correct?
Yeah.
So your median is still 12, because we added 2 numbers, so adjusted back to those 2 12s. All right. And the last question you should have answered, how did the measure of center, the mean and the median, change when these 2 people joined the class? So how did they change? When we added our person with 26 letters and then we added our person with 2 letters. How did it change our measure of center? Yes, Callie.
The mean decreased.
Did it only decrease? When we added 26, did it decrease? Okay, so mean increased and decreased, right? And then our median, what did our median do, Callie?
Our median stayed the same.
Yes. Alright. So, I just passed out a stack of cards. You should have 6 cards, one group has 7. Can you look to see who has 2, I think, letter D's? That's clearly I can't separate the paper. Nobody has 2 letter D's? You have what? 2 D's? Alright, so I need one of those back. Who has 2 of the same then? You have 2 A's, that's what I did wrong. Okay, cool. Alright, so for the next part, and we're only doing this last little activity, you are going to, in your group, essentially sort these graphs. You're going to sort them in piles of either mean or median. So which would be easier to essentially find the mean with and find the median with. Okay? Let's say 4 minutes. Hopefully it doesn't take any longer than that. Go ahead.
Size a household of 50 people.
No, don't write on these, please. Okay, don't write on these. Or, you know what, I'm not gonna, just sort them however you would sort them. Say it that way, based off of the data and the graphs. Mean is so mean, isn't it, Abby? You're like, Miss Kenny, shut up.
No, I said me 3 times.
Mean is the meanest thing. I mean, do you know what I mean?
You're making mean jokes.
I want to make, when I get my afro,
She's making mean times.
I am making mean memes.
oh my god.
And I'm done for the day. Quit.
No, you're making mean. Not mean.
Making mean memes.
No, mean.
It's like the best thing I've heard today. So honestly.
Alright, 2 minutes. How do you have them sorted?
The calculator is pretty cool.
Remember, you can sort them. You don't necessarily have to be like a median. But like, no,
B.
they're super high on the side.
Do you want to? I'm gonna tell this kid.
Guys, look for on the graphs, look for the ones that look similar. Okay? Disregard the mean and the median. I changed my mind. It's gonna be too hard to write. You guys do the math, and I don't want you to do any more math right now. Okay, so essentially like
Card D, B.
which one is someone says that?
No, I'm just.
Like strictly looking at that's the bar So that's really. Alright, let's go ahead and go over this. So I apologize, I made this harder than it should have been, and that is 100% my fault. So don't shoot the messenger. Okay, so looking at card F. Card F is the bar graph. I'm gonna borrow yours. Okay. Do you guys have another set of data that looks similar to card F? So which one, looking only at the data, is similar to card F? Kira, give me one of them.
Card D.
Card D. So let me see.
Card B.
All right. Why do these two look similar? I know you were not doing your cool down, child. You better not be. Promise. Why, Andrew, can I say that these two are similar?
Because the data is the same,
What do you mean?
so the median is basically the same.
Not necessarily true that the median is the same, but the location of the data is the same. So like the majority of our data is over here. And then we have a couple things sprinkled over here, right? All right, so is there another one that would fit into this category? So we have F and D. What is the other one that would fit into this category? Joe?
B.
B. I'm gonna grab B. You said B, right? Okay. So let's look at B. See if I have enough right up there. Do you guys agree? Do you agree that B looks the same as F and D? Some of us are saying no, some of us are saying maybe, and some of us are saying yes. Ben, you're saying no, why?
Because if you can, with the other card F and D, they are mostly on one side, and card B goes up and then down.
Right, so the difference between essentially F and D is the data is very high here and then low over here. The card B is, all of our data is very symmetrical. It goes up about the same, goes to a point, and comes down about the same. All right, so card B does not fit with these two other cards. So what card do we think could possibly fit better looking at the data now? Tabby?
Card E.
All right, so this is what card E looks like. Do we agree that's a better fit? Do you guys understand why it's a better fit? Okay, so Callie, you're saying no. Again, the majority of the data is at this side of the graph here, this side of the graph here, and this side of the graph here. Not a ton with this one, but it's still the majority of it is over there. Okay? Strictly looking at data points and bar graphs. That's it. We're not looking for anything else right now. So these three go together. Now, I'm going to pull card B back up here. Which one looks similar to B? Which one looks similar? So Callie, looking at B, which other card looks similar to B? Yes. So let's look at A. So do we agree that A and B look similar? They both have that same symmetrical going up and coming down. And then you have C, which it's a little bit more spread out, but it still has that same peak going up and coming down. Okay? All right. The little white pieces of paper, I am so sorry that they are not colored today. Don't shoot the messenger. These are your cool downs. I know, I've lost my mind. I did not put the cool down on a colored piece of paper today. I apologize. I was not thinking when I made the copies. So, cool down. Please go ahead and get started on it. If you do not finish, you can finish during, what's that class for the second? Science. And I'll get you your stuff. If you want to just grab my notebook, you can.